Alright, welcome back. This is part 2 of the lecture about surface temperature observations. It comes to you from chapter 2 of the Dessler textbook. Okay, so we are going to be talking about climate change in terms of temperature. Where are we going to get observations of temperature that are going to be helpful to us when it comes to describing climate? Well, let me tell you a thing about science in general. In general, there are two ways that we can measure anything, whether it's temperature or the mass of a planet or the size of a proton or whatever, any science thing. One strategy are what we call in situ observations. In situ is a Latin phrase that means something like on the site or right here, right now, or something like that. An in situ observation is taken when the instrument that is doing the measuring is actually touching what it measures. The thermometer is touching the air and it's measuring the temperature of the air. A scale in your bathroom is touching you and weighing you. Okay? This is in contrast to the other strategy in science for measuring something. That's called remote sensing. Remote sensing, broadly, is when the instrument that is doing the measuring is not touching what it measures. Telescopes. A telescope that is being used to take some observations of the moons of Jupiter is not touching the moons of Jupiter. It's billions of miles away. Radar. Radar, if you take ATS 113, you're going to learn all about radar, but it is a way that we use a station on the ground to measure and describe and make pictures of storms that are far away. Okay? Now, both of those strategies are used a lot in science, and both of them will be useful ways that we can get surface temperature observations. Now, in the case of remote sensing, it's not going to be radar, it's going to be satellites, but we'll get there. Let's focus first, though, on in situ observations. We're talking about weather stations here. Just so that we're clear about this term here, by the way, when we use the word stations in the context of like weather and climate, what we're talking about is a cluster of instruments that's at a fixed location. This isn't stations like TV stations or something. It's more sense of the word station as in it's stationary. We're going to establish a weather station at some location and it's going to stay there. And over very long periods of times, like decades, we're going to be taking weather observations at that fixed location. There are a few thousand weather stations in the United States that are officially run by the United States government. If I zoom in a little bit better here, you can get a sense there's a few dozen such stations in Nebraska alone. I'm not sure every station is plotted on this particular map that I happened to download from the NASA website, but it gives you a sense. There's many of them. A few hundred to a small number of thousand such weather stations around the country. In general, these weather stations are run by one of two federal agencies. Either the National Weather Service, which runs them for the kinds of purposes you would think they do, like making forecasts and providing severe weather statements and keeping people safe and so on, or the Federal Aviation Administration, who uses them as part of aviation safety. I mean, to know, to make forecasts, know the runway conditions and visibility and stuff like that for aircraft. These two agencies coordinate perfectly. And it's really actually quite transparent to meteorologists, any given weather station. It's quite, transparent isn't the right word. It doesn't really matter, okay? We have equally good access to the weather stations and their data, whether it's run by the FAA or whether it's run by the Weather Service. There's just subtle differences as to like who's paying for it and things like that. Here's an example of a weather station. This happens to be a picture of the weather station in Peoria, Illinois, to kind of give you a sense of what they are. They're usually out in the open like this, away from buildings and trees and things like that. It's actually very common that they're on some unused territory at an airport. Many, partly through the FAA, many weather stations in the United States are co-located with airports. And they're just this cluster of meteorological instruments that takes these official Weather Service observations. Normally they're configured to take these observations once an hour. A lot of these stations are unmanned. Routinely they're just taking these observations on their own and radioing them into some headquarters where they're processed and so on. And there's instruments here that are measuring the wind. You can see that wind vane and anemometer up there on a tower. You can see that there's instruments here, you might not know what those are, but those are measuring the visibility, how clear the air is and so on. And there's other instruments here that are measuring like pressure and moisture in the air and temperature inside of this little box. See how there's kind of like a little birdhouse over there? It's actually kind of large. That's called a shelter. It's actually, the right word is it's a Stevenson shelter. And a Stevenson shelter is this little louvered box that lets air float through but it's shady inside of that box. And that is where they actually measure things like the moisture and the pressure and the temperature. The observations are best taken in the shade. There are problems about taking temperature observations in the sun. You probably have noticed this before, like with bank thermometers along the side of the road. They're often ridiculously far off because the temperature might be taken in the sunshine, and the sun is just directly warming up the thermometer itself. You don't want the temperature of the thermometer, you want the temperature of the air. And the way you get the temperature of the air, rather than the temperature of the sunlight, beaming, well, it's not the sunlight warms up the thermometer and gets an unrealistic temperature. You take the temperature observations in the shade to correct for that. But what's a real key feature of these official National Weather Service and FAA observations is they are kept calibrated by professionals. There are professionals called MET techs, meteorological technicians, whose job it is to keep these instruments in calibration. If you're not familiar with that word calibrate, I kind of just cut and paste a definition here. It is to correlate the readings with those of a standard in order to check for the instrument's accuracy, to adjust, to take into account external factors in comparison with other data. They do things like make sure that the thermometer reads exactly 0 Celsius when the temperature is freezing, and exactly, they have calibration that makes the instruments accurate to, I think their tolerance is 1/10 of a degree Celsius or something like that. Okay, it's somebody's job. Their job is to visit those sites, I don't know, it's a certain number of times per week, and check to make sure all the meteorological instruments are very finely calibrated. There's no nonsense of the instruments have gotten out of calibration and they're giving false temperatures or anything like that. This technician's job is to make sure that these observations that are coming in from these stations are as precise and accurate as possible. I'm not going to get bogged down about the whole difference between precision and accuracy, because you've survived high school science, you know about these kinds of ideas. But it turns out that, as long as the measurements are fairly accurate, they're not off by some, calibration error. We didn't just leave that thermometer sitting there for 30 years and it got out of calibration or something like that. These real observations tend to be very, very accurate and precise, certainly to within at least 1/10 of a degree Celsius, which is pretty darn accurate. Now, in addition to these networks of hundreds and hundreds of weather stations that are officially run by the National Weather Service and the Federal Aviation Administration, there is a so-called Cooperative Weather Observers Network. Now, different federal agencies coordinate this, sometimes in collaboration with state agencies and universities and so on, that are recording not hourly observations of like the temperature and the wind and stuff like that, but just basic meteorological information at every little village out there in the country, out there. They record the high and the low temperature each day and the amount of precipitation. Very simple, basic weather information. We're not worrying about things that take specialized equipment like visibility or something like that. It's basically a rain gauge and a min-max thermometer. It's a special kind of thermometer that records the high and low temperature each day, kept in a nice instrumentation shelter. And there are zillions of these stations out there. Here I just have a map of the currently operating cooperative weather stations in a little area of eastern Nebraska. This extends from Omaha to about Grand Island in the east-west direction. And you can see there's a few hundred stations just in that region. In one of my other classes, we recently actually were doing a project using this data, and I think at the present time there's about 600 of these stations in the state of Nebraska alone. These are run by volunteers who are usually farmers, or I'll say busybodies, I don't know, people who have the time to each day check their min-max thermometer and their rain gauge, and they in some way report it. They used to actually have to fill in a little card each day and mail it. I think nowadays they somehow do it on the internet, but I don't really know. I've known a number of these people who do this over the years. They're usually people who have some interest in the weather, and they take a little class and then they get certified, and the Department of Agriculture or some other office issues them a min-max thermometer and an appropriate rain gauge and the information about how to report their observations. These are also good climate information, lots and lots of in-situ observations. And the quality of all these observations, whether they come from these official networks like the Weather Service and the FAA run, or from these cooperative weather observing networks with volunteers, the quality of them is maintained by the World Meteorological Organization. The World Meteorological Organization, it oversees the operations of the national meteorological services of every country on Earth. In the United States, we call it the National Weather Bureau. I'm sorry, the National Weather Service. Sorry, it was the National Weather Bureau in like the 60s. I don't know what made me think of that. But you can see every country on Earth has a National Meteorological Service. They all call it something slightly different, but they all are expected to coordinate observations in very much the same sort of way. A combination of official observations that are being taken at places like airports and so on, that are hourly and have certain quality and have professionals maintaining the calibration of the equipment, and then a much more detailed volunteer network that takes many more observations, may have be slightly less finely calibrated and so on. They don't go and visit those stations like multiple times a week. It's more like yearly or something, but provides amazing spatial coverage. All these observations quickly are entered into, okay, the hourly observations that come from the Weather Service and the FAA quickly relay into a telecommunication system and spread that data all over the world. They are quickly relayed through this system. It happens to be called the Global Telecommunication Service, relayed to the National Climate Data Center in Washington, or outside of Washington, D.C., to facilities in Switzerland, to facilities in Moscow, to the Bureau of Meteorology in Melbourne, Australia. Within moments, the observation taken by, say, the weather station at the airport in Omaha is all over the world. Okay, the observations that come in from cooperative weather observers, once they're in the system, they're relayed all over the world within no time as well. Why? Why are we getting those numbers all over the place? Why are the temperatures in Omaha quickly being archived in Melbourne, Australia, and Tokyo, and Moscow, and so on? Well, part of it has to do with the fact that those observations are going to be used to make weather forecasts. All of those national meteorological services are going to be making global forecasts of like where the temperatures are, where are the storms going, what is the weather next week. These kinds of short-range weather forecasts need temperature observations and wind observations and rain observations and so on. But in the context of climate, there's a particular reason why we quickly relay those information all over the world. And that is, we want to make sure that these observations are quickly available to lots of government agencies and lots of research institutions and so on. And the reason why we want to do that is to cover for ourselves about this idea that somehow climate scientists are faking climate change, okay? I mean, suppose you wanted to fake the results. You were going to somehow tamper with the temperature observations and impose some trend on them, add some numbers to them so that it looks like the temperatures are going up. Well, okay, you're some scientist in the United States and you start, somehow or other, you are applying some, the National Climate Data Center in Asheville, North Carolina, decides they're going to start adding a little bit to each of the temperature observations in the United States to make global warming look good. But almost immediately it would be caught, because the observations that are being stored at the National Climate Data Center in Asheville, North Carolina wouldn't match the ones being stored by the Bureau of Meteorology in Melbourne, Australia, which wouldn't match, or they wouldn't match the ones in Tokyo, or they wouldn't match the ones being stored in Moscow. We would very quickly catch that there is something going on here. Somebody is adding to the temperatures to impose a climate change that wasn't real. These kind of discrepancies would become immediately apparent. There is this idea that somehow scientists are tweaking the data. There's so many safeguards making sure that that does not happen, that can't be possible. The World Meteorological Organization oversees all these meteorological operations of every country from Afghanistan to Zambia, and they make sure that they all are meeting certain standards, that the observations are taken, for example, at very specific times a day. So like if you are supposed to be taking an observation that corresponds to a particular moment, okay, hourly at the top of the hour, etc., you aren't taking that observation 5 minutes later, or 10 minutes later, or half an hour later, because, like let's say you're talking about the observation at noon. Well, if you accidentally took that observation at quarter afternoon, it probably will be warmer. If you used to take the observations at 12, and now you take them at 12:15, statistical tools exist that would say, whoa, would be able to detect it's now warmer on average than it used to be, but that's just you're taking the observations at a different time of day. So the World Meteorological Organization makes 100% certain everybody's taking their observations exactly at the same time, under very specific controlled circumstances. The World Meteorological Organization specifies very detailed things about, like, how high above the ground the temperature observations have to be taken, how much air has to be able to flow through the louvers on those Stevenson shelters, exactly how white the outside of the Stevenson shelter has to be painted, even details about things like how often they have to clean those Stevenson shelters out because right away wasps and birds and stuff make their nests in there. How you calibrate, not only that the instruments are calibrated, but how you do it. The World Meteorological Organization holds these national meteorological services to a very high standard so that the observations can be trusted. They also ensure that the observations undergo some kind of quality control. I mean, in some parts of the world, the observations aren't automated the way they generally are in the United States. Somebody still have, in parts of, say, Africa, again, just because I'm an African meteorologist, I know a thing or two about that. In some parts of Africa, they take the temperature observations, and then somebody writes them down and takes them to a local internet cafe to enter them into the website of their National Meteorological Service so that the data can then get relayed to Switzerland and Camp Springs, Maryland, and Boston, and Moscow, and so on. Well, it's very easy to make a mistake, like to turn 2 digits around or something like that. There have to be some kind of quality control to make sure, whoa, we didn't just say that it is 19 degrees in Nigeria when it's really 91 degrees or something like that, okay? There have to be quality control procedures in place. Now, when you look, okay, so it's not so hard to see how we would do all of that over land. These kinds of observation networks over land, it's a huge effort to make it all work, but it's not terribly hard to see how it's done. What about at sea? I mean, I can look at this plot that comes from your textbook and see that, well, there are temperature anomalies all over the ocean as well. See those pink and blue colors there? Clearly, we had some sense that the temperatures were above or below normal over the ocean as well. How did we do that? Well, part of the story is buoys. There are networks of buoys out there that are collecting meteorological and oceanographic data. In my tropical meteorology class, we actually learn a great deal about how buoys work and what we do with buoys and so on. But there are lots of buoys out there. Now, buoys have all kinds of challenges. Maintaining the calibration on a buoy is tricky because it's out there, unmanned, birds are sitting on it, sea salt is getting sprayed on it. They're a challenge, and there aren't just tons of them out there. I mean, when you look at a global map of all the buoys at the present time, it looks like quite a few, but keep in mind that the oceans make up 70% of the surface of the Earth. I mean, we have buoys out there that are measuring temperatures and stuff, but there's not that many of them out there. Another way in which we monitor the climate and the weather and so on out over the oceans is through merchant ships. Most professional ships at sea that are hauling cargo routinely, like every 6 hours at least, reports back their current meteorological conditions. Temperature, moisture, rainfall, usually not rainfall. Rainfall is hard to measure at sea for complicated reasons, but winds, things like that, get relayed back to their home National Meteorological Service, and once they're in the system, they spread through the GTS just like the climate observations do, and other meteorological services can use that information. They do this because merchants, if you're on a cargo ship in the middle of the Pacific, you need good weather information. It's in every ship's best interest to have a good network of meteorological information so that they know where storms are and they have good forecasts and so on. So they're all highly motivated, and the calibration of these thermometers and so on is checked too. Just to give you a sense, here's 24 hours of data that came in from the merchant ship network. You can see how these little trails on there, that's like showing where each of the observations came in from a ship as it was moving over a 24-hour period. What I want to draw your attention to is this network isn't great. It's better than nothing, but, ships don't just sail out of their way to go look for storms or something like that. We have almost no observations in the South Atlantic or the South Pacific or whatever. That's why we have buoys out there and so on. Now, these are all examples of in situ observations, whether they come from an official network like the National Weather Service or FAA, whether they're taken by volunteers through the Cooperative Weather Observing Network, whether they are at sea from buoys or merchants. These are all really quite high-quality observations. All of these are well-calibrated, but that doesn't mean we don't have to be at least aware that there can be problems with surface temperature observations, these in situ temperature observations. There can be what are called inhomogeneities in the data. Inhomogeneities would be like an abrupt change that's artificial. Okay? The data used to say that the average temperature was about this, and then all of a sudden it says the average temperature is about this. What could cause that? Well, one would be change in instrumentation. I mean, if there was something, if they had a thermometer there, and it was working well, but they decided to upgrade it or replace it, and the new thermometer is biased, it's reading 1 degree colder than usual than the other thermometer would have. If you change out the instrumentation, you suddenly have an inhomogeneity in the data. You have to know this. You have to have statistical algorithms that can detect, wait a minute, all of a sudden there was an inhomogeneity in the data, and we have to make a correction for that. Okay, they have to document, oh look, we switched from this model of thermometer to this model of thermometer, and then the temperature's changed. We need to make a correction to that, all of which has been studied to death by all kinds of specialists. Urbanization and land use changes can result in inhomogeneities in situ observations. If your weather station used to be kind of out in an open field, and then one fine day the farmer who owns that field sold it, and they've paved it over to make a new Walmart, well, the temperature at that weather station is going to change because now it's surrounded by concrete. It used to be surrounded by corn, now it's surrounded by concrete. We're going to have more of an urban heat island effect, etc. These kinds of changes due to urbanization and land use can be very abrupt, and they are not global change. So we need to have ways, again, mathematicians, atmospheric scientists, climatologists have developed all kinds of techniques to detect when those kinds of problems happen in the temperature record and to fix it when they do. They document that there are changes, they document how they're fixing it, etc. There are always techniques to detect these kinds of inhomogeneities and then to correct for them as long as they can document, oh, I can see. I can show that this weather station was right where they developed a new parking lot, or I can show that this station got moved, or that this station they put a new thermometer in and it's not calibrated as well, or it's got other problems, or whatever. Now, before we move on to the other kind of observations, which were the remote sensing observations, let me ask you a couple more questions. Question 3. Which of these federal agencies does not operate surface weather stations? A. World Meteorological Organization. B. National Weather Service. C. Federal Aviation Administration. Okay, take a look at these 3 options. Choose one of them by following one of the links, and you'll get some feedback before you move on to question 4.